First, let's consider the use case of procurement of resources. We have developed a decentralized application to eliminate middlemen and automate the procurement process. Here, the Raspberry Pi acts as a node for our decentralized application, and we initialize the Raspberry Pi using SSH. Here, we have an application to order tools and resources. This application is connected to our decentralized network containing smart contracts. Once the order for the required resources has been placed, the distributor is notified and the payment is held in an escrow account with the smart contract. Now we move on to the step of procurement of the ordered resource. Once the order is delivered, an authorized representative of the company verifies the quality and confirms the transaction with his digital identity. Upon confirmation, a transaction is added to the blockchain. Once the block containing the transaction is mined, a smart contract releases the payment held, thus, issuing a notification to the distributor and transferring the liability. The distributor can look up the transactions on the Inventory Data Explorer. As we can see, the recently mined block contains the data of the latest transactions validated. Upon further exploration of the block, we find all the transaction details, and the distributor's transaction happens to be one of them. Now let's move on to another use case. Here we consider the case of measuring and automating resource management using smart contracts. As a proof of concept, we consider the case of electricity distribution and bill payment via decentralized application. Let's start our main blockchain node. As you can see, the node is active at port 5000. The next file to be executed contains all the smart contracts. Now we connect our device to the Raspberry Pi, which acts as a meter and measures the resource usage by the device. The Raspberry Pi is connected to the blockchain network and regularly updates the usage data onto the network. Let's upload some sample usage data for our device to the network in order to visualize it via our Block Explorer. As you can see, the resource consumption of our device is logged as transactions on the blockchain network. These transactions are finally mined by the nodes, thus adding a new block to the blockchain. Now we sign into the app in order to track our resource utilization. Every device has a unique meter ID which can be used to fetch its details on the blockchain. The app queries the blockchain network to compute any unpaid resource usage. The smart contract also keeps track of the resource utilization. In our example, if the unpaid usage exceeds a certain amount, the smart contract will automatically cut off the connection. Let's pay for the unpaid usage using the application. As you can see, all the details are stored on the blockchain network and the smart contract generates the final bill, hence, they cannot be tampered with. As soon as we pay the bill, the smart contract gets triggered and this payment information gets added to the blockchain network. The user receives a unique transaction hash which he can use to verify the transaction via the Block Explorer. Once the block containing the payment transaction is mined, the smart contract automatically unlocks the connection to the device by sending the signal to the Raspberry Pi. Finally, the device starts working again. This concept can be generalized to different measuring instruments like weighing machines, distance meters, etc., and smart contracts can be used to automate as well as validate the different processes involved. All the data from different devices can be used for building maintenance systems and building information modeling. In this way, by using blockchain, IoT and building information modeling in tandem, there is an opportunity to create leaner procurement systems and automate resource management, thus, building a simplified and secured infrastructure.